Okay, we're going to start getting into some of our properties of logarithms and building some skills so that we can solve log equations, so that we can expand expressions, condense expressions. These are all things that are going to be especially important for calculus, but also just solving any exponential or logarithmic equation, which we're going to see has a lot of different applications to it. So the properties of logarithms, because the logarithmic function and the exponential functions are so tied together as inverses, it makes sense that these log properties stem from the exponent properties. So let's refresh what those are. All right, so our exponent properties are this. If you are multiplying powers that have the same base, b to the m times b to the n, then you add the exponents to combine them into one base. If you are dividing b to the m divided by b to the n, we subtract the exponents. And if you do a power of a power, we multiply the exponents. The rules for logs are really exactly the same. So let's look first at the product rule. If you have the log base b of m times n, we can expand it to two separate logs using addition. So multiplication changes to addition. And so the way that we would do this, for example, here on number 1, this would become the log base 6 of 7 plus the log base 6 of 11. So they each get their own log, and now we're using addition. Notice the base stays exactly the same. It has to stay log base 6 the whole time, okay? Now for number 2, we have 3 things that are being multiplied inside here, 100 times x times y. Make sure you notice that's 3 separate factors. So we can write this as log of 100 plus log of x plus log of y. Now here's where you got to be careful. If I put this answer in my math lab, you'd get one of those notifications that would say, your answer is correct, but it is not in the correct form. That's because we always want to check and make sure that there's nothing else we can simplify. Remember, this is a common log, which means it's a log base 10. So this is saying 10 to what power equals 100. That one comes out evenly. Log of 100 is equal to 2. So that's how we would want to write this. 2 plus the log of x plus the log of y. That's the most expanded, most simplified form. And once again, this is because 10 squared equals 100. And this is a log base 10, even though it's not written there. Okay? All right. Moving right along, the quotient rule, division expands to subtraction. Make sure you keep an eye out for the same thing. Can we use any of our basic log properties? So to expand this is going to become the log base 8 of 28 minus the log base 8 of x. Now we need to check, does 8 to some power equal 28? No, it doesn't. So we're done. All right, number 4 is going to be the natural log of e to the 5th minus the natural log of 11. Now, is there anything more that we can simplify here? The answer is yes, because the natural log is the log base e. So this essentially says the log base e of e to the 5th, which remember, they undo each other and just leave us with 5. So that's the most simplified answer. Okay. The power rule. This is one of the most useful log properties that there is. The power rule, if I have the log of a power, it turns to multiplication. So the way that I always think about this is this exponent just pops out to the front. And so it comes out to the beginning there. Okay. So for number 5, the 9 will jump out to the front, and this becomes 9 log base 6 of 3. And we can't simplify the log base 6 of 3. Now, there are no rules for radicals, but that's because radicals are just exponents in disguise. This is equivalent to the natural log of x to the 1/3. We always switch everything to exponents, and this is a good habit to get into because in calculus, we never work in radicals. We only work in exponents. So we always have to switch everything. So the natural log of x to the 1/3, that 1/3 is going to jump out to the front, so that becomes 1/3 times the natural log of x. Okay, and then this last one, we can't do anything with that x plus 4. There's no rule for addition, but this does become 2 times the log of x plus 4. And that would be the answer. This is an important note. You can't split this up. You can't distribute a log. You can't, nothing like that, okay? That log is essentially like saying f. If I said f of x plus 4, we can't do something like f of x plus f of 4. That's not the same thing. In this case, f, the function we're doing, is log. So you can't distribute log. It's not a number. It's a name of a type of function. It's a logarithm function. So we have to leave it alone. Okay, so here are all 3 of those properties in one place, because very rarely is there only going to be one of these properties to deal with, okay? Now, the easiest way to think about this is to kind of follow the order of operations in a sense. So when we expand, here's the order that we want to go in, okay? All right, we're always going to start by expanding multiplication or division. Now pay attention to grouping, okay? So like if you look at number 9, we're going to have to do division before multiplication here because that fraction bar has got all this stuff in the bottom grouped together. So that's what I mean about pay attention to grouping. Always do your exponents last, okay? So if we look at number 8, inside this log, the first thing I see is that I've got multiplication. And so I'm going to expand that multiplication first. So I have the log base b of x squared plus the log base b. I'm going to rewrite this using exponents. That's always what we want to do. And there's no other multiplication or division here, so the last thing I do is bring my exponents out to the front. 2 log base b of x plus 1/2 log base b of y. Now that is our expanded form. Notice it's not necessarily simplifying. It didn't necessarily make it better, but it changed it to an alternative form that might be easier for us to work with. In calculus, that form is going to be much easier to work with than the original form. Okay, number 9, the first thing we have going on here is some division. So we're going to start by breaking up that division. So the log base 6 of x to the 1/3 minus the log base 6 of 36y to the 4th. Okay, now we look inside to see, is there any more division or multiplication? And there is. We have multiplication happening inside here. Now here's what's important. We are subtracting this entire logarithm. So anything that comes out of here, we have to also subtract. So we need to think of this as if it's in parentheses. Okay, so we have the log base 6 of x to the 1/3 minus the log base 6 of 36 plus the log base 6 of y to the 4th. Okay, so now we've got those split up. We can distribute that negative now and move our exponents because we're all done with everything else. So now this becomes 1/3 log base 6 of x minus, now here's where you have to be careful, the log base 6 of 36 is going to be 2 because 6 squared is 36. And then we have minus 4 log base 6 of y. So that is our most expanded and most simplified form. Now I want you to notice everything that came out of the denominator ended up with a negative in front of it. That's always going to be the case. So you can kind of skip that middle step by recognizing that anything from the denominator is going to have a negative in it. So will you pause the video, please, and try number 10 and 11 on your own? I'll come back with the answers in 3 seconds. Go ahead and put it on pause. All right, so here is our answer. Honestly, if I were doing this, I wouldn't have even written down that second line. I would have gone straight to the end because I know I need addition and I can go ahead and move the exponents at the same time. So that's fine. You don't need to show a whole lot of steps here once you kind of get the hang of how the pieces go together. So for number 11, here's how I think of this. Like I was saying in the previous example, anything that comes from the top of the fraction is going to be positive. Anything that comes from the bottom is going to be negative because of the division. Dividing turns to subtraction, but the top stays the same. So it's going to stay positive. So I know that I have 2 times x to the 1/2 in the top. So I know that the top is going to come from natural log of 2 plus the natural log of x to the 1/2. You might, go ahead and move the 1/2 now. That's fine. In the bottom, everything that comes out of there is going to be negative because we're dividing. So this is going to be minus the natural log of 25 minus the natural log of y cubed. You can go ahead and split it into pieces there. And if you're not quite making that connection, that's fine. Write it out in pieces and distribute the negative like we did on the previous example. But I'm trying to give you some tips on efficiency here so you can get through these a little bit quicker. So now we have the natural log of 2 plus 1/2 natural log of x minus the natural log of 25, which we can't evaluate, minus 3 natural log of y. And that's our most expanded form. Okay, the last thing we're going to look at is condensing, which is working in reverse. So if it's already expanded out, how do we switch it to a single logarithm? This is really important when we're solving equations, okay? So we're going to do this in the exact reverse order. So before, the last thing we did was put the exponents back. Here, that's going to be the first thing we do. Put back your exponents and then combine. You always want to work left to right in pairs, okay? Left to right in pairs after you put your exponents back. So for number 12, I don't see any exponents to put back. How would I know? It's because you'd have a number in front. So like on number 13, that 4 and this 2 is an exponent that needs to go back. So nothing to put back on number 12. But we are going to have the log of 25 times 4 because we multiply. Addition goes to multiplication. We're going in reverse. So this is going to be the log of 100, and we've already seen before that's equal to 2. All right, number 13. Go ahead and pause the video. Try 13 and 14 on your own, and I'll come back with the answers here in just a second. Exponents first, left to right in pairs. 3 seconds. All right, here's what you get when you put the exponents back. Now, with this, it's exactly the same thing. Anything that's positive goes to the top of a fraction. Anything that's negative goes to the bottom. So I have, if I move left to right in pairs, like I said, the first pair is this, addition. So that's going to come together as log base 3 of 5x to the 4th minus the log base 3 of y cubed. And now all I have left is a pair. That's going to become division, log base 3 of 5x to the 4th over y cubed. Now again, I likely would have gone straight from here to the end because I know anything positive, the x to the 4th and the 5 is going to be on the top. Anything negative, which would be the y cubed, is going to be on the bottom. Notice that our final answer has just a single log in it. That's it. That's what we're expecting. So for number 14 then, we really only have 2. Remember, there's no way to break this up. It's stuck in the parentheses there. But we do have division, so this becomes the log of 7x minus 6 over x. And so that would be your final answer. Last thing for today is the change of base property, okay? So we have seen that your calculator does common log, base 10, and your calculator does natural log, base e. So how do we do other bases? Now, you may have a button on your calculator. Some of the newer ones do that let you pick a base. That's fine. You still got to know the change of base property because we're going to use it to simplify in a whole bunch of different ways, okay? This needs to go on a flashcard. So the idea is this. If I have the log base b of m, I can change that to a common log by the log of m divided by the log of b. Or I could change it to a natural log of m divided by natural log of b. Okay, so let's look at 15 and 17 first, because they will both give us the same answer. It just depends on the context. Like I said, in calculus, we only ever work in base E. So we only use natural logs. So that's what we're going to want to do in calculus. If you are working in something where you're measuring in the metric system, maybe you want to switch it to common log. So it just kind of depends on what you're trying to introduce. Okay, so the way you would set this up to type this into your calculator for this first one is going to be the log of 140 divided by the log of 5. Okay, your calculator will automatically open parentheses. Do make sure that you close it before you divide. If we want to do that using natural logs, we would say the natural log of 140 divided by the natural log of 5. Go ahead and put those into your calculator, and you should see no matter which one you choose to do, we get the same answer. And because they are equivalent, you should get 3.070. Same thing here, 3.070. Okay. So go ahead and do those last two examples, 16 and 18. For number 16, I want you to use common logs. For number 18, I want you to use natural logs. And let's come up with those answers. I'll be back in 3 seconds with the last answers for today. There are your answers. If that's not what you're getting, then it's probably something about what you're typing into your calculator. So make sure we get a chance to look at that the next time I see you. And that is it for our log properties.